Hey guys, we're gonna get started with 14.2 here. So you'll want your notes packet out and you want to flip to the 14.2 page. And in this lesson, we're gonna dive a little bit deeper with probability. And then we're also gonna learn about what a complement is. So we're actually gonna skip the objective box for today. I think you'll get the idea as we go here that we're talking about more probability and complements. And then we're also going to skip this review section here. And we're going to move along to a couple problems that involve a standard deck of playing cards. And these are things that are going to come up quite a bit in the probability unit. And some of you are more familiar with cards than others. So I'm just going to kind of summarize really quickly here. In a standard deck of cards, there are 52 total cards. And those cards are broken up into what we call suits. There are 4 different suits. There are clubs. Those are the guys that look like clover leaves. There are spades. They look like upside down hearts. Those are your black cards. And then there are hearts. And there are diamonds. And there are 13 of each of those. Okay. And then these are called aces in that column. And then 2, 3, 4, 5, 6, 7, etc. All the way up until the J. J stands for Jack. Q stands for Queen. And the K stands for King. And there are 4 of each of those. And these are often just called your face cards. So there are 12 total face cards if we were to count all of those up. Okay, so hopefully we're a little bit familiar with a deck of cards. Let me know if you have any questions with those and I can help you out with cards. So first problems here, they say find the probabilities for only drawing 1 card using a standard deck of playing cards. So the probability of picking out a diamond, well, there are 13 total diamonds out of 52 total cards. And that turns out to be exactly 1/4 of the deck. So the probability would be 1/4 there. Probability of drawing a 4. There are 4 4s out of 52 cards. And that reduces. Each of those are divisible by 4. And that will reduce to 1/13. Face cards, we just talked about that. There are 12 total face cards out of 52. And that ends up reducing to, let's see, what would that be? 3 out of 13. If we divided those each by 4, we would get 3/13. And then letter D says a red face card. So a red face card would be these 6 right here, would be our red face cards. So 6 out of 52, which would be 3 out of 26 as a reduced fraction. Okay, now we're going to look at a couple and or problems. So or means either one. And means it has to have both, I'm going to say both properties. Okay, so if we look at an example here, it says either an ace or a red. So if I go back up here, I'm going to circle all of the aces, so there's 4 of them, or a red card. So these are all of the red cards. Now, we don't want to count these 2 twice. We got to make sure we only count them once. So be a little bit careful there. We have 1, 2, 3, 4 aces, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 out of 52 would be either aces or red. And that should reduce. We can go down to 14 over 26 and 7 over 13. I think is about as good as we can do on that one. Okay. Now we're going to go to an and problem. So ace and red. That means it has to be both an ace and a red. So in other words, a red ace is what we're looking for. So if we go back here, that's actually just that overlap. That's that one that we counted twice. There are 2 of them. There's the ace of hearts and the ace of diamonds. So there would be 2 out of 52, which is 1 out of 26. Ooh, that was kind of bad. 26. I'll try that again. Okay. How about a heart or a club? Well, 13 of them are hearts and 13 of them are clubs. So altogether there would be 26 of those out of a total 52, which is exactly half of the deck. Half of them are either hearts or clubs. And then H is kind of a trick question. It is saying how many ways can we get a heart that is also a club? A heart and a club. Remember, we need to have both of those properties. Are there any cards in a deck that are both a club and a heart? No, that doesn't make any sense. So that would be impossible. Zero. 0 out of 52 or just 0. We flip the page here to page 4. This one says on your own, so if you would like to try this one on your own, go for it. If not, you can probably get enough practice on your worksheet. So we're going to move on to complements here. This is kind of the meat of the lesson here. What a complement is it is basically your failures, you're not successful, or what I might say is like the rest of the group. Or maybe you want to think of it as like the opposite of what you see. Okay, so I think the best way to explain this is to just look at an example. So it looks like in this example, for A, B, and C, we're going to be rolling a die. So this is for A through C. We're just doing this guy here. Okay, so I am first going to list what could happen if we're rolling a die, and I'm going to go over to the side here. So what could happen is we could get a 1, 2, 3, 4, 5, or 6. This is rolling a die. That's our sample space. Okay, now what this means is this means the complement of P, or the complement of picking a 2. So it's the opposite of 2. So I'm going to write that. I'm just going to draw an arrow to here. Okay. This little apostrophe means complement. So what this means is this means not a 2. You could just read it like that. What is the probability of not getting a 2? Well, the probability of getting a 2, or you would be successful if you got a 2, we want not that. We want the opposite of that. So we would do 1, 2, 3, 4, 5 out of 6. The probability of not getting a 2 is 5 out of 6. Okay, I'm going to do it again. 1, 2, 3, 4, 5, 6. I'm just going to list it again. Probability of not getting an even. Okay, so here is not an even, not an even, not an even. There are 3 of those. 3 out of 6, which is the same as 1/2. Okay, and then letter C, 1, 2, 3, 4, 5, 6. We want to not get a 5 or a 6. So maybe you want to cross them off. Maybe that makes more sense. Not a 5 or a 6. There would be 4 possibilities left, which is the same as 2/3. Okay, for this second group here for D, we're going to be flipping a coin. We're going to just be flipping a single coin. This is for letter D. So the probability of not getting a tails would be getting a heads. So there would be a 1 out of 2 chance or 1/2 chance of getting not tails, which would be the same as probability of getting a tails. Maybe I'll put that over here. So heads, tails, we want not tails. So 1 out of 2. Okay, and then this last one, this is your seasons. Okay, so what are the seasons? We have fall, winter, spring, and summer. Okay, so what is the probability that it's not winter? Well, if we got rid of winter, we would have 3 out of 4 left. Okay, so complements are actually quite simple. It's just kind of the opposite, like I said, the opposite of what you see, not winter. So cross off winter and see what you have left. All right, and then last example here, bear with me for one more. It says organize the data and answer the following questions. Geometry classes are made up of 28 freshmen, 248 sophomores, 98 juniors. 42 of the juniors are female. Okay, there's a lot of information going on here. So we need to organize it. So we're going to organize our table like this. We're going to do boys and girls. We're going to do freshmen, sophomores, and juniors. Okay, and then we're going to organize our table. So it says there are 28 freshmen. So all together, this is our total amount of freshmen is 28. there are 248 sophomores, and there are 98 juniors. I think this example was made when we taught geometry to mostly sophomores, and now it's mostly freshmen, but that's okay. All right, and then we're going to read here. It says 42 of the juniors are female, so we're going to find the junior column, and 42 of them are girls. Now, if there were a total of 98 juniors altogether, and if 42 of them were girls, then we would be left with 56, which are boys. And now we have 168 of the sophomores are male. So 168. Okay, so 248 minus 168, that would leave us with 80 girls. And then the freshmen are equally divided. So we need to divide 28 by 2. So that'll give us 14 boys and 14 girls. Okay, so that'll help us organize our data so that we can more easily answer these questions. So first one is probability of a freshman girl. A freshman girl. Well, before we even do that, we need our total number of people. So I'm going to write total here. Total number of people. 28 plus 248 plus 98 is 374. Okay, so if we are looking for the probability of a freshman girl, that would be 14 out of 374. All right, and I'm actually going to leave these as unsimplified for this one. I don't want you to get in the habit of that, but for the sake of time here, we'll just leave them that way on this. So letter B, probability of not a freshman girl. Not a freshman girl. So we would basically want to do 374 minus 14. It'd be the opposite of what we just answered for letter A. So if 14 of them are freshman girls, then there are 360 out of 374 that are not. So maybe I'll show the math over here. 374 minus 14 is 360. Okay, probability of male. So our male our male row, our boys, goes this way. There are 238 of those if we were to add all of those together. So probability of a male, 238 out of 374. And then not, or the complement of male, not male, would basically be the same as girls. So we could do it either way, or we could just do our 374 minus 238. That would be 136 out of 374. Okay. Now a male, or let's see, I'm going to add this here first before I forget those were our girls. Male or a junior. So we have lots to do there. So our juniors would be those two, and then our males would be those guys there. So we would want to add all of those together. Maybe I'll let you do that on your own. 14 plus 168 plus 56 plus 42 all over our total 374. All right, and then male and junior for the last one. Remember what that means? That means it has to satisfy both. They have to be junior males. Junior males. So that would just be this 56 here. All right, so it got a little long again. Hopefully you're not mad. Go ahead and practice. Let me know what questions you have as you go through your practice.